Okay, we're going to try this kind of challenging log problem here. Question 6. Let's just get started. They tell you that this graph here is the graph of f of x equals the negative of log to base b of x. And they want you to prove that b equals 2 if you're given that there's a point on this function, f of x is 4 and y is minus 2. Well, you guys should know that the first step is what you've got to do is substitute the point into the equation to solve for b. So you do that. You put in minus 2 for y, and you put in 4 for x. And that's you're on the way. So this first part's not too bad, really. Multiplying both sides by -1, you get 2 equals the log to base b of 4. And you have to know that there's the base, so you put the base down there. The log is the exponent, so you put it on top. It's b squared equals 4. Hey, so b must equal 2. So that part wasn't too bad. So we really know that this equation is the negative of the log to base 2, base 2 of x. So we know that actually is the function that we're dealing with. Okay. Now write down the inverse. Now, how do we do this inverse? Now, this is a little bit tricky with this negative thing. It made it a little bit harder. But the first thing wasn't tricky because all you did was switch x and y. Switch x and y. Oh, that's how you do an inverse. You get reflection in the line y equals x. Now, this negative here, though, isn't nice. You have to multiply both sides by -1 and make it negative x over on this side. And now you're ready to do the question. You can say that there's your base to this power, that equals y. That's how you can change logarithmic form into exponential form. And there's your answer. Y equals 2 to the minus x. But it's a lot nicer to have it in this form, y equals 1/2 to the x power. At least it is for me, because I can see what's going on here. Like y equals y to the 1/2 x power. Oh yeah, that goes this way. Y equals 2 to the x, the most basic exponential, goes off to the right. This one goes off to the left. Why does that work? 2 to the minus x is, because 2 to the minus x is 2 to the minus 1 to the x power, and 2 to the minus 1 is 1/2. Well, let's see if we can do the next two questions. Now this question, explain how you transform f of x into h if h of x was 2 to the minus x minus 5. Well, we got that the inverse was 2 to the minus x. Well, you have to picture what's going on. Here's the function they gave us, and it hit down here at 4 and minus 2, and it goes like through here. They didn't tell you it goes through 1, but it does. And what's the inverse about? How does that work? Well, everything would just switch. Instead of 4 and minus 2, you'd have minus 2 and 4. It's like this line y equals x is a mirror. And instead of getting super close to the positive y-axis, it's super close to the positive y-axis. And it goes through the same point here and here because it's just the inverse. The x value here becomes the y value here. Well, there's a picture of it. So the question is, how would you take the original one? Well, the first thing you did is you'd reflect it in the line y equals x. So they want to know when you say find the inverse that you're reflecting it in y equals x. And then, it says minus 5. So you just say in words that you'd move it 5 units down. So here's the green inverse, and then you'd move it 5 units down. So you have to explain in words what you would do, how you'd get that. Well, you get the 2 to the minus x by just reflecting it in y equals x. And you get the minus 5 by shifting it 5 down. So it's not too hard when you really think about that one. Okay, let's take a look at this one. Now this one is a little bit annoying for me in a way. You know when they say determine the values for which the log of x to base 2 is less than 3, they want you to use the graph. Look at this memo with all these different things thinking about this graph. Now, you could just go straight to it. This is what I did. They asked this question. I went 2 cubed is equal to 8. So what values of x would I put in here that would make this less than 3? The log to base 2 of 8 is 3. It must be everything between 0 and 8. So I have the solution by just putting this in logarithmic form and finishing. But I don't know if you get any marks for that. Feels like the logical way and the best way is the simplest way. But if you've got a graph, they want you to use it. So what you do is if you multiply both sides of this by negative, you'll get your graph. This graph is, let me go back and grab this. This graph is y equals the minus the log of the base of 2x. Okay, that's the function. So they want you to use that one. So you multiply both sides by a negative, and you're clever to remember to reverse the inequality sign. And now you multiply both sides by -1. Now you can go 2 cubed equals x. So x must equal 8. And if you look at the graph, you're saying, where is f of x, the y values, greater than -3? Well, it's this place. And where does that happen? In between x equals 8 and in between x equals 0, the y-axis. So it's in between 8 and 0. So that is very nicely using the graph to come to your solution, which is a nice 1, 2, 3, 4, 5, 6, 7 step thing, which seems like feels like you should get something. And this is a 2-mark question, so I don't know. But there you go. That's how you do it. I think this is how the memo is, so that's the way they would like you to use the graph. Yeah. So there you go.